So we're going to start by looking at the review sheet for energy. On this review sheet, it gives you a picture of a ball going down 3 different ramps. And so they want you to describe the acceleration of the ball traveling on track A. So we'll go through this problem 1. So on track A, we would describe the acceleration as less to begin with, and then it increases as it moves to the end. Okay. On track B, since the slope of that track is constantly the same, we would say that it has a constant acceleration because the slope is not changing. On 3, looking at that one, you can see where the track is steeper at first and then it gets less steep, so the acceleration is great for the first part. And then it would be gradually decreasing as it moves. The acceleration would. Okay. Now, they want you to describe the velocity of the ball traveling on track A. On track A, we would say that the velocity increases at an increasing rate. And the slope gets steeper, so it's going to keep increasing. On track B, since that slope is constantly the same, we'd say the velocity increases at a constant rate. On C, we're going to say the velocity would increase at first very fast, rapidly, and then it's going to not increase as fast for the second part. So we could say it's a decreasing rate. So they want you to rank the time for the balls to start to finish and then explain your ranking. So if we were to rank the balls from start to finish, since ball C increases its acceleration rapidly at first, it's going to have increased its speed more. And since B is going to always be a constant rate all the way, and then on A, it's going to have a increase at a slower rate to begin with, so it would be a little bit less. So if we did this, if we did a velocity versus time graph for these 3 balls, for C, it increases fast at first and then it slows down, so that's what C would look like. For B, the velocity is increasing all the time and it's at a constant rate, so that means this would be a line with the slope being the same, so that would be B. And for A, it's going to increase slow at first, and then it would increase faster at the constant rate, like that. So if you were to look at this, the one that would traveling, if we rank the time, C would have the shortest time, B would be middle, and A would be the longest time, because of the way that they increase their speed. We're going to get you started on these problems. Now it says rank the instantaneous velocities of the ball at the mid-height and explain your ranking. So when you want to look at this, you want to look at the energy transformation here. So we're really going from energy gravity into energy kinetic for this, plus they still have some energy gravity. Okay? So if you looked at each ball there, if you wanted to rank their instantaneous velocities at the mid-height time, I want to go back and look at the picture. So if you look at the mid-height time is right here. Notice all three of these, no matter where the ball is, it has the same height. So it has the same energy gravitational here. They all started out at the same energy, so they all had the same energy gravitational here. Now, and they all go through the same change in energy gravity, and that energy gravity is changing into energy kinetic. So that means, since these balls all have the same mass, they're identical, their energy kinetic must also be identical. So that means, and since their masses are identical, that means they're going to be the same velocity. Instantaneous velocity would be the same for each one of them. Because this value is the same, this value is the same. Well, guess what? This value has to be the same too, because we know energy is conserved. Now, the next one, they want you to rank the instantaneous velocities at the mid-range line, so you need to go back and look at that. So if you look at the mid-range line, which is this one right here, right there's the mid-range line. Now if you look at this, if A is here, yes, it changed its energy gravitational, which it had here, to this. B is here, and C is here, but you can see C underwent a greater change in energy gravitational, and so that is being stored now as energy kinetic. It's really the same thing here, except the difference is the energy gravitational that they changed was different. So that would mean that at the one that has would be C, then it would be B, and then it would be A. Okay? So due to the difference in the change in height, which has to do with that energy gravity, C had the greatest, change in height. Okay? So then that means it's going to have the largest velocity. Okay? Then it says for J, they want you to rank the velocities at the finish point. At the finish point, since they all have the same change in H, which your energy is being stored from gravity to kinetic, these should all be identical again. Okay? So that should get you started with that worksheet. I'm looking at problem number 12 here. And so 12 kind of incorporated some things that we had looked at earlier. And so somebody is pulling this block, which is 50 kilograms, to the right. And then they told you what mu was when it is moving, what the coefficient of friction is. So the first thing is you're supposed to draw a force diagram for this. So my force diagram will look something like this.